Square and square roots. Introduction to square numbers. How many stamps are there? 1 stamp. How many stamps are there? 1, 2, 3, 4. 4 stamps. Now how many stamps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stamps. Now count the number of stamps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now how many stamps are there? Is it difficult to count the number of stamps as the number increases? So easily we can find the number of stamps by multiplying the number of rows and the number of columns in each case. Let us see in the first case. There is 1 row and 1 column. By multiplying 1 by 1, we get 1. There is only 1 stamp. In the second case, we have 2 rows and 2 columns. So by multiplying 2 by 2, we get 4 stamps. In the third case, we have 3 rows and 3 columns. By multiplying 3 by 3, we get 9 stamps. In the fourth case, we have 4 rows and 4 columns. Thus, by multiplying 4 by 4, we get 16 stamps. In the fifth case, by multiplying 5 by 5, we get 25 stamps. In all these cases, did you observe that we are multiplying the same number by the same number? After multiplying same number by the number, we get 1, 4, 9, 16, 25, next 36, and so on. All these numbers are called square numbers. How can we define square numbers? The product of a number multiplied by itself is called a square number. One into 1 is equal to 1 square, which is equal to 1. 2 into 2 is equal to 2 square, that is equal to 4. 3 into 3 is equal to 3 square, which is equal to 9. 4 into 4 is equal to 4 square, which is equal to 16. 5 into 5 is equal to 5 square, that is equal to 25. 6 into 6 is equal to 6 square, which is equal to 36. Similarly, n into n is equal to n square, that is equal to m. Here m can be expressed as n square, where n is a natural number, so that m is a square number. Is 28 a square number? We know that 5 into 5 is equal to 5 square, that is equal to 25. 6 into 6 is equal to 6 square, which is equal to 36. 28 lies between 25 and 36. If 28 is a square number, it must be the square of a natural number between 5 and 6. But there's no natural number between 5 and 6. Therefore, 28 is not a square number. 1 can be written as a product of 2 equal positive integers, 1 into 1. Can 1 be written as the product of 2 equal negative integers, that is minus 1 into minus 1. 4 can be written as the product of 2 equal positive integers, that is 2 into 2. And 4 can also be written as the product of 2 equal negative integers, that is minus 2 into minus 2. Similarly, 9 can be written as product of 2 equal positive integers, that is 3 into 3, and 9 can also be written as product of 2 equal negative integers, that is minus 3 into minus 3. And the remaining square numbers can be written as product of 2 equal integers. Such numbers are called perfect squares. Perfect squares. The numbers which can be expressed as the product of two equal integers are called perfect squares. 1, 4, 9, 16, 25, 36, and all the square numbers are also called as perfect squares. This table shows the first 20 natural numbers and their corresponding squares. Did you observe that a square number always ends with 0, 1, 4, 5, 6 or 9? There's no square number that ends with the digits 2, 3, 7 or 8. Does that mean that any number ending with any of the digits 0, 1, 4, 5, 6 or 9 is a square number? No. All the numbers ending with 0, 1, 4, 5, 6 or 9 are not square numbers. Is 65 a square number? 65 ends with the digit 5, but it is not a square number. Let's explore some more properties of square numbers. Observe that if a number ends with the digit 1 or 9, then its square ends in 1. Similarly, the square of a number that ends with the digit 2 or 8 ends with 4. And the square of a number that ends with the digit 3 or 7 ends with 9. In the same way, if a number ends with the digit 4 or 6, then its square ends with 6. And if a number ends with 5, then its square ends with 5. Also observe that the squares of even numbers are even, and the squares of odd numbers are odd. Now observe these numbers and their squares. Can you find any pattern in the number of zeros at the end of these numbers and their squares? The number of zeros doubles on squaring the number, and the square number has even number of zeros at the end. We have learnt about properties of square numbers. Now let us learn about some interesting patterns of square numbers. Rahul is playing with marbles and likes to arrange the marbles in triangular pattern. Let us see how he is arranging them. He takes the first marble, places it. Now he takes some more marbles and arranges them in a triangular pattern. How many marbles are there? 3. He's adding more marbles to make the next triangle bigger. In the third triangular pattern, how many marbles are there? 6. In the fourth triangular pattern, how many marbles are there? 10. What do we call these numbers which are 1, 3, 6, 10, and so on? We call them as triangular numbers. Let us see by adding consecutive triangular numbers, what do we get? By attaching one marble to the second triangular pattern, we get a square. By adding 1 and 3, we get 4. 4 is nothing but the square of 2. Similarly, by attaching second triangular pattern and third triangular pattern, we get a square. So by adding 3 and 6, we get 9. 9 is nothing but the square of 3. If we combine two consecutive triangular numbers, we get a square number. Let us see some more interesting patterns of square numbers. We know that 1, 4, 9, 16, 25, 36, and 49, and so on are square numbers or perfect squares. Are there any natural numbers between square numbers? Yes. What are the numbers between 1 and 4? 2 and 3. Between 4 and 9? 5, 6, 7, and 8. between 9 and 16, 10, 11, 12, 13, 14, and 15. Similarly, between any two square numbers, there will be natural numbers. Let us take the first number between 1 and 4, which is 2. Can we write 2 as the product of two equal integers? Is it possible? No. Similarly, can we write 3 as the product of two equal integers? No. So what do we call such type of numbers which we cannot write as the product of two equal integers? We call them as non-perfect squares. We know that 1, 4, 9, 16, 25, 36, 49, etc. are consecutive square numbers. Do you know the number of non-perfect squares between two square numbers? Let us learn the pattern of numbers of non-perfect square numbers between two square numbers. Here, how many non-perfect squares are there between 1 and 4? Yes, 2, which are 2 and 3. Similarly, how many non-perfect squares are there between 4 and 9? 4, which are 5, 6, 7, 8. And the number of non-perfect squares between 9 and 16 are 6. Let us see what is the pattern behind it. 4 and 9 can be written as 2 square and 3 square respectively. The number of non-perfect squares between 4 and 9 are 4. 4 can be written as 2 into 2. Similarly, the number of non-perfect squares between 9 and 16 are 6. 6 can be written as 2 into 3. Here 3 is the square root of small square number. The common pattern that you observe for number of non-perfect squares between two square numbers is the product of 2 and the square root of the small square number. This can be represented as n square, n plus 1 the whole square, which is 2 into n equal to 2n. The formula for the number of non-perfect square numbers is equal to 2n. Find the number of non-perfect square numbers between 49 and 64. 49 is equal to 7 square. 64 is equal to 8 square. 7 square is like n square and 8 square is like n plus 1 square. Here n is equal to 7. N square into n plus 1 the whole square. N is equal to 7. Number of non-perfect square numbers is equal to 2n, which is equal to 2 into 7, that is equal to 14. Find the number of non-perfect square numbers between 1296 and 1369. Is it easy to write 1296 as the square of a number? Is it easy to write 1369 as the square of a number? It is difficult. So we have another easy method to find the number of non-perfect square numbers between perfect squares. By subtracting smaller square number from the bigger square number and subtract 1 from the result, we get the number of non-perfect squares between two consecutive square numbers. In this case, subtract 1296 from 1369 and subtract 1. We get 72. Therefore, the number of non-perfect squares between 1296 and 1369 is 72. Let us summarize what we have learned. If a natural number m can be expressed as n square, where n is also a natural number, then m is a square number. All square numbers end with 0, 1, 4, 5, 6, or 9 in the units place. Square numbers can only have even number of zeros at the end. The number of non-perfect squares between two consecutive square numbers, n square and n plus 1 the whole square, is 2n.